The Sun consumes about 4 million tons of hydrogen per second. Despite this colossal rate of consumption, the Sun has enough hydrogen to keep burning for approximately another 5 billion years, thanks to its immense mass. Eventually, the Sun will lose up to 30% of its current mass. During the red giant phase, the Sun will expel a significant amount of its mass in the form of stellar wind. This will gradually affect the orbits of planets, causing them to drift away. Could Earth survive the Sun's red giant phase? Well, in theory, yes. If Earth isn't engulfed by the expanded Sun, the loss of solar mass could cause Earth's orbit to move far enough to avoid vaporization. However, life as we know it wouldn't withstand the extreme conditions. The Sun's red giant phase is relatively short-lived. Despite spending about 10 billion years on the main sequence, its red giant phase will last only about 1 billion years, a mere blink of an eye in cosmic terms. The Sun's ultimate fate is to become a white dwarf. After becoming a white dwarf, the Sun will shine for billions of years, albeit with a fraction of its current brightness. Eventually, it will cool and darken into a black dwarf, a theoretical state not yet observed due to the age of the universe. Planetary nebulae are the remnants of stars. The Sun's red giant phase will result in the formation of a planetary nebula, a colorful shell of ejected gas and dust, which is the remains of the star's atmosphere. These nebulae are crucial for recycling material in the interstellar medium, contributing to the formation of new stars and planets. Black holes and the Sun. For the Sun to become a black hole, it would need to have about 20 times its current mass, highlighting the unique and powerful nature of black holes in the universe. Imagine yourself gazing up at the sky on a starry night, marveling at the beauty and vastness of the universe. At the center of this universe, at least for us here on Earth, is our Sun, a source of light and life, essential for existence as we know it. But like all stars, the Sun has a life cycle, and eventually, it will come to an end. So what would happen if in the distant future, our Sun were to transform into a black hole? This video delves into this hypothetical scenario, exploring the stages of the solar life cycle and the implications of this transformation for the solar system. Our aim here is not only to satisfy curiosity about an almost unimaginable future, but also to provide a deeper understanding of the cosmic mechanisms at play. Let's unravel the mysteries of astrophysics in a way that everyone can grasp, using scientific concepts, informed speculation, and, of course, a dash of imagination. Are you ready to embark on this journey through time and space, contemplating the ultimate fate of our Sun? Then, adjust your telescopes and get ready for a celestial exploration like no other. Let's deepen our understanding of the fundamental astronomical principles essential for exploring the ultimate fate of the Sun and its influence on the solar system. The Sun, our primary source of light and heat, is a dominant stellar force that governs the orbits of the planets, asteroids, and comets that make up our solar system. At the heart of this incandescent giant, nuclear reactions occur, transforming hydrogen into helium and releasing immense amounts of energy in the process. This energy, essential for life on Earth, results from nuclear fusion, a cosmic ballet of subatomic particles under extreme conditions of pressure and temperature. The life cycle of a star like the Sun is fascinatingly complex. It begins in a nebula, a cloud of gas and dust, where matter coalesces under the force of gravity, eventually forming a main sequence star. In this phase, the star shines by fusing hydrogen in its core, a process that in the Sun will continue for about 10 billion years in total. Half of this time has already passed, signaling that the Sun is in a relatively stable stage of its life. However, the Sun's destiny holds dramatic changes. After depleting the hydrogen in its core, the Sun will expand, becoming a red giant, a phase characterized by a significant increase in size and a reduction in surface temperature. This period marks the beginning of the end for the Sun as we know it, eventually leading to its transition into a white dwarf, the final stage for stars of similar mass to the Sun. The conversion of a star into a black hole is a phenomenon reserved for celestial bodies of colossal masses, far beyond those possessed by the Sun. A black hole forms when the core of a supermassive star collapses under its own gravity at the end of its life, creating a region of space from which not even light can escape. For the Sun to become a black hole, it would require a highly hypothetical and speculative scenario involving cosmic processes beyond current understandings of stellar physics. This exploration of astronomical fundamentals sets the stage for a journey through the possible final phases of the Sun, and how such transformations would impact the planets, including Earth, in the solar system. Understanding the nature and behavior of stars is crucial for appreciating the magnitude of the forces at play in the cosmos, and the consequences of these forces for the future of our own planet. As we advance in our cosmic journey, we reach a crucial chapter, the ultimate fate of the Sun. This incandescent giant that lights up our days is destined for a spectacular transformation that will forever alter the face of the solar system. Over the next billions of years, the Sun will consume all the hydrogen in its core, marking the end of its main sequence phase. This will trigger a series of stellar events that fascinate and unsettle us in equal measure. The transformation begins when the Sun, having depleted its hydrogen, initiates the fusion of helium into heavier elements like carbon and oxygen. This process results in the Sun expanding to colossal dimensions, transforming it into a red giant. The expansion is so vast that it's believed to engulf the nearest planets, such as Mercury and Venus, and perhaps even Earth. During this phase, the Sun's brightness will increase dramatically, but its surface will become cooler, acquiring a distinct reddish hue. After this expansion phase, the Sun will shed its outer layers, creating a stunning planetary nebula, while the remaining core contracts to form a white dwarf. The white dwarf, the dense remnant core of the Sun, will be extremely hot initially, but without a source of nuclear energy, it will gradually cool over billions of years. The notion that the Sun could become a black hole is intriguing, but as mentioned earlier, highly unlikely due to its insufficient mass for such a transformation. For a black hole to form, the Sun would need a mass several times larger than its current mass. Therefore, while we explore this hypothetical scenario, it's important to note that based on our current understanding of stellar physics, the ultimate fate of the Sun is to become a cold, dark white dwarf, a silent whisper of the once blazing giant it once was. This scenario puts into perspective the impermanence of everything in the cosmos, including our own star. Yet, it provides a fascinating glimpse into the stellar transformations that occur over billions of years, shaping the evolution of the universe. The transformation of the Sun into a red giant and, subsequently, into a white dwarf will have profound repercussions throughout the solar system. This futuristic scenario not only reshapes our understanding of the Sun's destiny, but also raises intriguing questions about the future of the planets orbiting around it, including Earth. As the Sun expands to become a red giant, its gravity will also undergo changes, affecting the orbits of the remaining planets. The closest planets, already consumed by the solar expansion, will cease to exist, while those that survive may have their orbits extended or altered due to the loss of mass as the Sun sheds its outer layers. This process could lead to orbital destabilization and the reconfiguration of the planetary arrangement as we know it. The surviving planets will experience drastic changes in their surface conditions. With the decrease in sunlight and the increase in orbital distance, the temperature on planets like Earth will drop significantly, potentially leading to an extreme ice age or even a completely frozen world. On the other hand, the red giant phase of the Sun could temporarily increase the temperature of these planets before they become cold and dark. The issue of the possibility of life, both on Earth and on other celestial bodies, becomes even more pressing under these extreme conditions. Life as we know it relies on a delicate balance of conditions, many of which will be irreversibly altered. Unless life can adapt to extreme environments or migrate to other regions of the solar system or beyond, the prospects for survival seem bleak. Despite these grim predictions, the universe is a place of constant renewal. The nebula left behind by the expulsion of the Sun's outer layers could eventually become the cradle of new stars, and perhaps even new planetary systems. This cycle of death and rebirth is fundamental to cosmic evolution, suggesting that even in destruction, there is room for the creation of new forms of matter and perhaps life. Exploring the ultimate fate of the Sun and its impact on the solar system not only captivates our imagination, but also underscores the importance of scientific thinking and astronomical research. To fully comprehend this distant future, we turn to the brightest minds in astrophysics and the technological advancements that allow us to glimpse the mysteries of the universe. Astrophysics experts offer valuable insights into the stellar life cycle with research based on detailed observations, computational simulations, and theoretical models. They help us understand not only what to expect when the Sun eventually expands and transforms, but also how these events fit into the broader context of stellar evolution. Interviews with these experts or quotes from their research can enrich our understanding of the complex cosmic processes at play. Current and future technology play a crucial role in observing and understanding the universe. Advanced telescopes, both space-based and ground-based, continue to expand our knowledge of distant stars, nebulae, and other celestial phenomena. Space missions dedicated to studying the Sun, such as the Parker Solar Probe and the Solar Orbiter, provide invaluable data on solar activity, its structure, and the forces influencing its life cycle. These technologies not only enhance our current understanding but also pave the way for future discoveries. Looking at other stellar systems that have already undergone transformations similar to those the Sun will face offers a window into the possible future of our own system. Observing stars in different stages of their life cycle, including those that have become red giants or white dwarfs, gives us clues about stellar behavior and the consequences of these transformations for orbiting planets. Studying systems where black holes already exist helps us better understand the dynamics and extreme gravitational effects that accompany these mysterious objects. When considering the fate of the Sun and its impact on the solar system, we are reminded of our own finitude in the vast theater of the universe. This reflection encourages us to value scientific knowledge and research as essential tools for unraveling the secrets of the cosmos, and perhaps finding ways to transcend our cosmic destiny.